All right, today we're taking on a crucial algebra skill. We're going to be adding and subtracting radicals. So the first thing that I want you to know is that when you're adding or subtracting radicals, they must have the same radicand. The radicand is simply the number that is underneath the radical. So in order to combine them, we have to have the same radicand. So I'm going to add that right up here. So must have the same radicand. Okay, and all that word means, that radicand is the number underneath the radical. Okay, and then all of my examples, we're looking at square roots. So when I look at my first example, I have 2 square root 5 plus the square root of 5, right? It's implied that there's 1 square root 5, okay, minus 7 square root 5. So when I look at all of these, I have 3 separate terms. They're all in terms of the square root of 5. So they do have the same radicand, so I can go ahead and combine them. They are like terms. So I take their coefficients. I take the 2, the 1, and the minus 7. Okay, I'm going to combine those and leave it in terms of the square root of 5. So 2 plus 1 is 3, minus 7 is negative 4. So I have negative 4 square root 5. Okay, to compare it to something else, it would be like if I have 4x plus 5x. We know that those are like terms. They're both linear terms. 4x plus 5x would make 9x. But if I said, what's 4x squared plus 5x? I can't push forward. Those are not like terms. So when it comes to radicals, when we're adding or subtracting, we must make sure that we have the same radicand. They have to be like terms in order to combine them. Okay, and then for this sheet right here, I'm going to do all of the odds. I want to give you guys some examples, and then I want you to pause, and I want you to work through the evens on your own. So now I'm going to look at problem 3. So in problem 3, I have 3 root 6, so 3 square root 6, minus 2 square root 5, plus 4 square root 7. So right away I can see that, well, this is a 6, that's a 5, and that's a 7. And I can't simplify each of those individual terms. I'm stuck. So this is actually totally simplified. There's nothing else I can do. I'm going to write that. This is totally simplified. Okay, there are not any terms that I can combine further. So my answer is exactly as the problem starts, 3 square root 6 minus 2 square root 5 plus 4 square root 7. Sometimes it's just that easy. All right, next up, problem 5. So at first glance here, I have 4 square root 3 minus the square root of 27 plus 5 square root 12. So these radicands, they don't match either, but what I am noticing is that that square root of 27, I can simplify that, so I should. And that square root of 12, I can simplify that, so I should. So let me go ahead and simplify these terms first and then reevaluate. So here I have minus the square root of 27. So square root of 27. I know that's 9 times 3. 9's a perfect square. It's going to give me a pair of 3's with this 3 staying behind. So I know that this becomes 3 square root 3. So I had that 4 square root 3 to start, minus 3 square root 3. And then over here I have 5 times the square root of 12. I usually underline that 5. I don't want to forget that it's there. And the 12, I know that that's 4 times 3. And 4 is a perfect square. It gives me a pair of 2's. So here I really have 5 times 2, which is 10, square root 3. So by taking the time to simplify each individual term, I'm actually now seeing that the radicands all match. They're all in terms of the square root of 3. So now I can combine. 4 minus 3 is 1, plus 10 is 11, square root 3. All right, next one up. Okay, problem 7, I have the square root of 243 minus the square root of 75 plus the square root of 300. So again, at first glance here, these are not the same radicand, but I know that I can simplify each individual term more. So I'm going to do so. So when I look at 243, I can see that that is 81 times 3, and 81 is a beautiful perfect square, right? It's a pair of 9s. So I know that that first term really becomes 9 square root 3. Okay, next term, here I'm subtracting the square root of 75. 75 is 25 times 3, and 25 is made up of a pair of 5s. So that second term is minus 5 square root 3. Okay, and lastly, the square root of 300, I know that that is 100 times 3. 100 gives me a pair of 10s. So that last term simplifies to be 10 square root 3. So now when I look at all of my individual terms, I see the same radicand. They're all in terms of the square root of 3. So I can combine the 9, take away 5, that's 4, plus 10 is 14, root 3. Okay, so now what I'd like you to do is I'd like you to pause this tape, and I want you to work through problems 2, 4, 6, and 8, and then check it against my answer key that's available online, or you can watch me work through these last 4 problems. So again, pause and then unpause when you are ready. Okay, here we go. Let's do the right-hand side. All right, so here in problem 2, I have negative 3 root 7 minus 6 root 7 plus root 7, right? They're all square roots. So they're all also the same radicand. Again, to add or subtract, I have to have the same radicand, that same number underneath the radical. So I'm going to take that negative 3, take away 6, so I have negative 9, and then plus 1, and I have negative 8. So I have negative 8 root 7. Okay, next here I have negative 6 root 3 plus 2 root 11 plus the square root of 20. So these first 2 terms, I know that they're simplified. There's no pair in 3. There's no pair in 11. But that square root of 20, there's going to be a pair in there, because the square root of 20 is 4 times 5. So that 4 will give me a pair of 2's, and that 5 stays behind. So I saw that I could simplify this term, but only this term, and then I'm going to look at it one more time. So I have negative 6 square root 3 plus 2 square root 11 plus 2 square root 5. And now that I look at it, I see that even though I could simplify that square root of 20, it's simplified to be 2 root 5. There's nothing else I can do. I don't have any more like terms. I don't have the same radicand, and I've already simplified. So this is my final answer. There was simply nothing else I could combine. Okay, next up, 6. So here I have 6 square root 50 plus the square root of 32 minus 5 square root 8. So here again, I don't have the same radicand, but I can see that each term can simplify further, so I'm going to go ahead and do that. So here I'm going to underline that 6. I don't want to forget about it. And that 50 is 25 times 2. 25 is a perfect square. It's made up of a pair of 5's. So I have 6 times 5, which is 30 square root 2. Next term, that square root of 32. Well, I know that that is 16 times 2, and that 16 gives me a pair of 4's. That 2 stays behind. So plus 4 square root 2. Okay, lastly, I have the minus 5 square root 8. I'm going to underline that minus 5. I don't want to forget it. And then resolve that square root of 8. So square root of 8 is 4 times 2. 4 is going to give me a pair of 2's. There's going to be a 2 that stays behind. So I have 5 times 2, that's 10, and then square root 2, just like that. So I've done my job. I've simplified each of those 3 terms, each one. And in looking at them, they're all in terms of the square root of 2. So I can push forward and combine them. So 30 plus 4 is 34 minus 10, and I'm at 24 root 2. So 24 square root 2 would be my final answer. Okay, last one, problem 8. Let me just slide that up. So here, when I look at each term, I'm seeing the same thing. I'm seeing that, they don't match. None of these match. I do not have the same radicand. So what I need to do is I need to simplify each individual term first. So square root of 98, I know that that is 49 times 2. 49 gives me a pair of 7's with that 2 that stays behind. So it simplifies to 7 root 2, or 7 times the square root of 2. Okay, next, I see that minus 5 square root 72. I'm just going to underline that 5 part so I don't forget about it. And then 72, I know that that's 36 times 2. So here's a pair of 6's. Here's that 2 that stays behind. So negative 5 times 6 is a negative 30, so minus 30, and then square root 2 right here. Okay, and then lastly, I have minus the square root of 200. So 200 is 100 times 2. And 100 will give me that pair of 10's, and here's that 2 that's going to stay behind. So minus 10 root 2, or 10 square root 2. So now when I stand back, I look at it, I see, they all have a square root of 2. How great. So I can combine them. So 7 minus 30 is a negative 23. Minus 10, I'm at a negative 33, and then root 2, or square root 2. That's my final answer. All right, that's all I got. Have a good rest of your day.